Hey guys, we're getting ready to go live. Woo-hoo-hoo-hoo. All right, we're getting ready to go live. Hey guys, we're getting ready to go live. Woo-hoo-hoo-hoo. All right. All right, let's get this put in. Hold on 1 second. All right, I'm just going to shoot out another quick message. Just so people know that we're going live right now. Thank you for the people who've already signed in. That's fantastic. Just do a new one right here. Yeah, actually, that's not what I want to do. I'm going to do this. All right, thank you for being patient as people sign on. I just want to send one more notice that I'm going live right now. I didn't even snap it out, but that's fine. Okay, perfect. Hello, welcome. So glad to see you guys today again for some of you. That's really great. My plan was originally to do proofs today. However, for those great people who stayed after school, we did not get as much done as I wanted to for Trig. I wanted to have more of you have a solid foundation in Trig. And man, there's just a whole lot of gaps. So I know right now I already started it to go live, but that is why we're going to be doing Trig. Now we will be doing Trig in class. We will be going through some of these same questions. In some of your classes, I'll probably even just show the video. But I can't believe how many things we forgot about Trig. So that's why we got to do Trig. And I'll do a longer one about proofs later. But the proofs one is probably going to be a good hour, hour and a half. And so I'm thinking I'm just going to save that for the weekend. And that's the current plan. So here we go. First things first, because this is Trig, we were playing Kahoot and we were getting a lot of questions wrong. And it was kind of frustrating for some people because, you know, you get in this habit of like, man, everything's got to be right. Hello, welcome. And it's okay to get things wrong right now. Like, it's totally okay today to get things wrong. Perfect. I love that. Perfect, perfect. So it's totally okay to get things wrong tonight. What's not okay is to get things wrong in the beginning of tonight and not improve and get better, and then not work on this in the future. But there's probably going to be a couple questions about Trig on your EOC. The great news is that it's not going to be on your district assessment. And I can say that with certainty because right triangles in Trig specifically, I don't know if you'll see a squared plus b squared or c squared, because that kind of goes overflow with distance formula. So that part might be on it, but actually like sine, cosine, and tangent will not be on your district assessment final because it's a unit 3 topic. And your district assessment final is on unit 4, unit 5, and unit 6. So that's kind of it, but it's all right if it takes a long time tonight to get to it, all right? If there's one night that you need to have paper and pencil, it is tonight because you don't have these questions yet. So you can do them a second time in class, or you can use paper and pencil right now to go through them. Not all of these are going to be on the papers I give out to you in class. All right, next we have this. So this is geometry formula sheet that you will get for the EOC. Now, here's something that's amazing. The sets of equations that you need to do well on Trig, right here at the top of the formula sheet. So it's not like you have to memorize SOHCAHTOA, SOHCAHTOA. If you all remember that song that I played for you last year, you don't got to remember that because it's literally right here. What you do have to remember is that it's on the formula sheet and you have to remember how to use it. But that's kind of the mindset. So don't stress yourself out about, oh, I got to remember these things. You don't. You have to remember that they're on the formula sheet, and then you have to remember how to use it. So first things first is Pythagorean Theorem. Most people, hey Soraya, most people got this stuff good, all right? Because we did this unit 4. We did this already when I was teaching you distance formula. Actually, we did it in unit 6, I think, where I had you, we went to the media center library, and basically I had those videos that I did, and sometimes I was in your class, sometimes I wasn't, because I think I had the doctor's appointment thing. And basically, like, you watched a video and I said, you must watch this, you can watch this, and then you played some games with like flying ants and asteroids, and then it went to distance formula and circles. So I was trying to activate your prior knowledge that you have seen this with me this year. So hopefully these will be quicker for us to get along. The main thought to think about for here is that this c squared is always going to be considered your hypotenuse. So here it is. The hypotenuse is always the side that's opposite the right angle. So here's my pretty, why am I using the mouse on the touch screen? Here is my pretty right angle. The side that's not touching it, the side that's opposite it, that's the hypotenuse. Now, it is going to be so incredibly important that you remember to label the hypotenuse for every single one of these trig problems. Now, the good news is that this part doesn't really matter. Like, this can be leg A, it also could be leg B, and you would still get it right. This says leg B, but it could also be for A, and you would still get it right. The only time that you'll get these problems wrong is, one, if you did the math incorrectly, but mostly if you did not put the hypotenuse as the c in the c squared. So let's take a look. Here we go. Right now, I'm going to not immediately start. I want you to please go ahead and try to do these. And the main thing is, actually, I will model the first one. The first thing you're going to do is you're going to draw your right angle. Here's my right angle. Hello, right angle. It's so nice to meet you today. Then you're going to look at the side that's opposite the right angle. This is called the hypotenuse. Okay? Now that you have the hypotenuse, you know what the rest are. This has to be a leg. And in this case, it's actually what we're trying to get. And this has to be our other leg. So I'm going to just take a breath while you draw this picture on your paper. I know I go fast, so I'm going to slow down. Now we're going to write down our a squared plus b squared equals c squared. Now we're figuring out where things go. It doesn't matter the a or b. That doesn't matter. So I'm just going to put x squared here, but it truthfully doesn't matter. Then I've got my b. Well, here's my b, my other leg. And then here I've got my c. So then I got to keep going. Well, if I had a calculator, oh, I closed it already. 11 squared is 121. 14 squared, I believe, is 196. So let me do it on the calculator. Ginger sees something outside, and she's been barking like crazy. So I apologize. See, there she goes. 196. And then pretty much there's a dog like a good 50 feet away on the other side of the fence, and that's what she's hearing. When I subtract 121 from both sides, I get 75. Excuse me. Excuse me, please. Ginger. All right, we're back. Now we have our x squared here. Well, the opposite of squaring something is taking the square root. So if I do the square root of 75, I'm going to get, oh, I got to change my mode. I'll get 5 square roots of 3. Guys, I'll be right back. Go ahead and start working on this problem because I just got to close the windows because she's got to chill herself out. So I will be right back. I know, we all hear you, Ginger. Don't worry. No. All right, I am back. Thank you. I'm sorry for that. Hopefully we won't have a problem again. So, did anyone get the answer to the second one? The answer to the first one is 8.6. Okay. All right, I guess we'll keep going then. So basically for this one, it's the same idea. Here is my right angle. Opposite that right angle is my hypotenuse. So this is going to be one leg, and this is going to be the other leg. We don't know what this leg is, so we're going to write x. So we've got x squared plus 8 squared equals 10 squared. That gives us x squared plus 64 equals 100. X squared equals 36. Take the square root of both sides, and x equals 6. Now, I know I went fast on this. I'm going to expect that you watch this again if you need to. Most of you know Pythagorean Theorem, so we're going to keep moving on. Okay, this is the most important thing today right here. I'm so sorry that my dog was like being loud and people, you know, stepped away, but you need to know this, okay? This is on the formula sheet. The main idea, and you have this in your notes, is that we use trig ratios to find lengths, and you use inverse trig ratios to find angles. So trig ratios, lengths, inverse, angles. If you have your notebook, you should do this. Trig, length, inverse, angle. And the reason why you should write this down is that's one of the things I need you to remember. If I had you today, I talked to you about similarity, and the thing I needed you to remember is sides proportional, angles same. Here you need to remember trig length. Trig ratios are for length. Inverse is for sides. So trig is for the length, inverse is for the side. Or we can even say inverse, or wait, I was so misspoke. Trig is for the length, inverse trig is for the angle. You got to remember that. Okay, I'm still riled by Ginger. Okay, so if I go down here, you already did these tips. The main thought, and I would be surprised if you did not see a question like this, is something that relates to sine A and is the same as cosine B. And all that pretty much means is this. So here's where it says the side, you use the sine, cosine, and tangent. Angle, you use the inverse. What they mean by this is here. Here's my triangle ABC. If I find the sine of A, and you might not remember the sine of A, that's okay. But if you have the sine of A, let's say this is 4, 5, and 6. It won't be, but let's pretend. The sine of A gives you 4 over 6 because sine is opposite over hypotenuse. But if we look at what's the cosine of B, well, here's our cosine of B. Here's my adjacent. And here's my hypotenuse. So I get 4 out of 6. So this relationship of like complementary acute angles, the inverse, like, or not the inverse, but like being flipped. So like sine A, cos B, that is something that I would expect that you're going to end up seeing. Okay, let's move on. I know I'm going a little bit fast because I did put together a lot of things for us to cover. And I want to make sure we cover it because you can always watch this video again. So here it says find sine C. It wants to know what's the relationship for sine C. All you're going to do is, we're looking at the original paper. Oh, I thought I put it up here. I didn't. Okay, so sine C is, oh, I put it in reverse order. Let's go down. We're going to skip down. Here we go. This should have come here and I should have put it up. So here, these are the formulas that you need. And again, this is right here what you're going to see on your formula sheet. You just have to know how to use it. Here they wrote the whole thing out, the length of the opposite side, the length of the hypotenuse. That's how you determine what the ratios are. But the main idea is that you're going to be using the opposite hypotenuse, adjacent, opposite, adjacent. So when we come back up here, let's take a look. For sine, the formula is opposite over hypotenuse. Okay, so I've got sine theta equals opposite over hypotenuse. Now, the whole idea with theta is whatever this is the angle you're talking about. And so it's the same idea of theta as we did for unit 4 circles. So the angle you're talking about. So in this case, we're talking about theta being C, because that's the angle that we're talking about. We're talking about C. So for the opposite side of C, that's going to be 21. That's our opposite. The hypotenuse is whatever is opposite the right angle. So here, this would be our answer. That's it. You don't necessarily have to put it into a decimal unless they ask you to put it into a decimal. Some of the things we're going to see today, it is in a decimal, and some of the things we're going to see today, it's as a fraction. Here we have it again. Here's our sine C. We have our sine we know is opposite over hypotenuse. We know that because we looked at the formula sheet, or you remember SOHCAHTOA, SOHCAHTOA. So what's our opposite side? Well, just if you were at the after school review today, I told you the opposite side is like on the other side of the table. So we're going to cross this triangle table to get to the other side. That's 30. The hypotenuse is the one that's always opposite the right angle or the longest side. This one you should reduce to get 3/5. And I reduced by dividing the numerator and the denominator by 10. All right, I'm going to keep zooming on. So if you didn't finish writing everything down, good, watch the video again. Love you. All right, this is different. This is cosine. Looking at the formula sheet, you'll know that cosine is the same thing as adjacent over hypotenuse. Okay, now here it tells you it cares about cosine C again. So we're going to label it. Here's my opposite. Here's my hypotenuse. So this has to be my adjacent. So my adjacent number is 36. So I'm writing 36. And it's adjacent to C because C is the angle I'm talking about. C is theta. Then 39 is my denominator. Hopefully you might notice that 36 and 39 are both divisible by 3. So this would reduce to 12/13 is the ratio for cosine. Again, C is the angle we're talking about. Cosine is adjacent over hypotenuse. Sometimes I tell kids just write your hypotenuse first because it's the easiest. It's the biggest number. The adjacent one is always the one that makes up the rest of the angle, and this would be the hypotenuse. It would really behoove you or be a really good idea if you drew triangles for every single one of the trig problems that you're going to get on the EOC and label it, because you're not going to be able to label it really on the computer screen, I don't think. Again, cosine is adjacent hypotenuse. Okay, so my adjacent number is 8. My hypotenuse is 17. So that's my ratio. It's literally that simple. It's just plugging it in. The hardest part is knowing which side is which and knowing which trig identity to use if they don't tell it to you. Okay, here's another one. Here's tangent. Tangent is the only one that doesn't use hypotenuse. Tan is opposite over, excuse me, tangent is opposite over adjacent. Wow, that's really large. That's still large, opposite over adjacent. So basically, hey Jazz, welcome. Now we're going to do the same thing. Now it wants us to look at tan A. So here's my A. I'm going to say, okay, which is which? Well, here's my right angle. The biggest number is my hypotenuse, which is sitting across the table. Well, across the table, opposite the table, is my opposite. And the other one that makes up with the hypotenuse, the angle, is my adjacent. So it wants tan, wants opposite adjacent. So my opposite is 12. So I'm going to write down 12. My adjacent is 35. And that's it. Let's look at another one. Here's my x. Well, let's label it. My opposite is the number that's across from the x. Opposite. Adjacent makes up the angle. Adjacent. So I will have 36 over 27. Here's the kookity dookity thing. Sine and cosine will always be a number less than 1. Always. It's not the case for tangent. Tangent could have a number, any number less than 2. I don't know, maybe you could even have higher than 2. Tangent, it just doesn't matter. Cosine and cosine will always be less than 1. Excuse me. We did that already. So now that we did those review questions, we are going to jump into these EOC questions. These EOC questions come right from the book. Okay, and when I say the book, I mean the book that the Georgia Department of Education puts out for you to do better on your EOC. So I didn't create all those other ones I kind of created. This I didn't create. Okay, here we go. Find the ratio of the side opposite angle B. So see how it says angle B? Angle B is my theta. This is the angle I'm talking about. To the hypotenuse. So it wants opposite and hypotenuse. Well, because it says opposite and hypotenuse, if I look down here, I'm looking which one of these has opposite and hypotenuse. Sine has opposite hypotenuse. So I know I'm going to write sine B. And this right here is on one of the papers you're going to get on Thursday and Friday this week. Sine B. So then I'm looking at, all right, what's my opposite side? Well, my opposite side from angle B is 8. My hypotenuse on this triangle is 10. So really we would reduce this to either 4/5 or 0.8. It depends on what they expect of you. Then it says what angle, so that was A. Now we're going to look at B. It says what angle in triangle DEF. So let's erase all this that we don't need. What angle in DEF, so we're looking here, corresponds to B. Well, hopefully you can see how it matches up. But here's my right angle. And then here's A to D. So we see how A matches to D. B matches to E. And C matches to F. So we would say angle E. Angle E is the same type of angle in here. Remember today I talked to you that when we deal with similarity, I told you that sides are proportional, but the angles are always the same. Okay, so because of that, that's why they're the same. Even though the triangles are smaller, the angles remain the same. Letter C, find the ratio of the side opposite angle E to the hypotenuse in DEF. So now angle E is what we're talking about. Opposite, that means we're doing sine. And hypotenuse, because sine hypotenuse we said down here, opposite hypotenuse. So we've got 4, so we've got sine of E equals 4/5. Which, ooh, look at that, it's the same. So letter D says, how does the ratio do it? Well, letter D, okay, the ratios are the same. And that's one of the things that is also the same besides the angle measures are the trig identities. Because the trig is the same in similar figures. Okay? And sim triangles. So which trigonomic ratio does this represent? And we've already been doing it. That would be sine. So I know I'm going a little faster on here, but anyway, sine. But you can always pause it and watch it again later. We're going to trash this. Okay, here's another one. Now it gets tricky. So I've got the formulas on the bottom that we need. It says Ricardo is standing 75 feet away from the base of a building. So here's our building, and here's our Ricardo. Ricardo is pretty tall compared to the building. The angle of elevation from the ground is 32 degrees. So this is the angle we're talking about. Our theta equals 32. And what is x, the height of the building to the nearest foot? So we're going to say, you know, this picture might be a little bit confusing. So I'm going to just draw a triangle down here. Here's my theta. Here's my right angle. And I know that I've got x here and I've got 75 here. So if I think about it, if this is my angle, this x represents the opposite. And this 75 represents the adjacent. because this diagonal is the hypotenuse. So I know I have opposite and I have adjacent. So we're going to look down here and see. Well, here's opposite hypotenuse, and I don't have the hypotenuse, so it can't be that one. This one says adjacent, which I do have, but you also need the hypotenuse. I don't have a value for the hypotenuse, so it can't be that one. Tangent says opposite adjacent, so that's the one we're going to use. We're going to use tan. Okay, so then all you do is, since it's multiple choice, that would be it. Tan of 32 degrees. How did they get the 0.6249? Well, tan of 32 degrees. And then, that's the formula. That's why. Equals, well, what's our opposite? X. What's our adjacent? 75. Now it tells you the values. It tells you tan of 32 is 0.6249. So if you didn't know how to do it on your calculator, it gave it to you. Basically, this is how you do it on your calculator. You won't have these calculators. You're going to have the school or the computer calculators, but you've been practicing with it because that's what I've been making you do. There's a button on there that says tan. On this calculator, it's above the parentheses. So now I wrote down tan. Then I would type in 32 and close my parentheses. So it looks like this. And then when you hit enter, you get the value that they gave you. Okay, so that's how you would do it if you had a calculator. Now, all you're going to do is good old cross multiplication. This times this equals this times this. So you've got x equals, and then we're going to do 0.6249 times 75, 46.86, and it wants to the 10th of the foot. So if you're not good at rounding, don't be a fixed mindset. Look at the video I made last week. It wants to the 10th, so I know I need to look at the 8. I'm going to look at the number next to the 8. It's a 6. Because it's a 6, I know I'm going to go up. So my answer is 46.9. Ta-da! All right, I did more work than you really needed to do. Most times, you would just be able to look at it, but I really wanted to explain it. Here comes our next one. The airplane has an altitude of 5,900 feet. The airplane descends at a 3-degree angle. So here it's descending at 3 degrees, and basically all they did was use alternate interior angles to make that degree, 3 degrees. I'm going to erase that because you don't need to know that, but that's what they did. How far will the airplane travel in the air until it reaches the ground? So we're looking at how long is the descent right here. So if this is the angle we're talking about, because we need to use an angle that's inside the triangle, we know that here's my right angle, so this is the hypotenuse, because the hypotenuse is the longest side, the hypotenuse is opposite the right angle. Here's my 3. Well, if this is my table, I'm going across the table, so I know this is opposite. So I have opposite and I have hypotenuse. So we're going to look down here. Opposite, hypotenuse, shebang. That's what we're using, sine. It tells us sine of 3 degrees is that value. So we're going to write down sine of 3 degrees equals opposite over hypotenuse. Well, basically our sine of 3 is 0.0523 equals our opposite value, which is 5,900, divided by our hypotenuse, which is x. Now we got to cross multiply again. This is where it gets tricky because you're actually just going to be dividing, because you're going to get 0.0523 with the x equaling 5,900. Now we're trying to get the x by itself, so that's why we're going to just be dividing. Some kids don't even have to write out the proportion. They know right away to just divide when x is in the bottom. 0.0523. Did I do that right? Yes, I did. So I got, actually, let me check my notes when I did it earlier, because this number is huge. I have it down as 20 miles. Yep, I'm right. Holy moly. So it's going to be 112,810 point, what does it want? To the nearest, it doesn't tell us. It says 0.7, so I'd probably just round it to this. Okay. And that's going to be feet. And that seems like a lot of feet, but if you divide it by how many feet are in a mile, it ends up being like 21 miles. Wow, that was a big problem. All right, we actually are almost done, okay? So we're going to keep pushing through. That's this first one. Trash it. Scroll. Okay, we're not doing all 34. All right, now I'm switching over to needing to know how to do angles. In this case, they give us the sides. We need to find the angle measure. Okay, so whenever we need to find the angle, I told you that you're going to use your inverse. So the identities are still the same. The thing that's different is the inverse. So let's just label. Here's my theta. So that means that I've got opposite, and it means I've got the hypotenuse. So opposite hypotenuse means I'm doing sine. So I've got sine of theta equals my opposite, which is 39 over 44. This is what you're going to type in the calculator. You would type in the calculator sine inverse parentheses 39 divided by 44 parentheses. And let me show you what I mean. On the calculator, you have your sine, cosine, and tangent buttons. Right above it in green are your inverses. So on the calculator you're going to need for the EOC, and I will show it to you in class, you're going to have to hit the second button to go up to the next. So I'm just going to hit second, and then I'm going to hit sine, and now I have my sine inverse. Then I'm going to type in 39 divided by 44. Literally just like that, like as a fraction or as a division problem. Then I hit enter and I'm going to get a value. And that's going to be my answer. So in this case, my answer is 62.41 degrees. Okay, let's look at another one. Here is my angle I'm talking about. I know that here's my right angle, so this has to be my hypotenuse. And I know this has to be opposite, so this is another sine. Because I'm trying to find the angle, I'm going to hit the inverse button. And then I'm going to type in my opposite, which is 26 divided by my hypotenuse. Ooh, that looks really cool on the gray. So let's do it again. Here's my calculator. I'm typing in second sine because I need to get that inverse. Okay, your cell phone calculators also do this. Then I'm typing in 26 divided by 33, and I have to close the parentheses so the calculator knows when to stop. Then I hit the equal sign, and I get my value. In this case, 51.98. Okay, let's look at this one. Here's my angle. I have my adjacent because that side is touching my angle. And I have my hypotenuse because the 36 is the longest side. It's opposite the right angle. So now I know I'm going to be using cos. So I have cos A equals 24 over 36. So in my calculator, I would do cos inverse 24 divided by 36. So I'm going to hit the second button. I'm going to hit cos so I can get the cos inverse. I'm going to type in 24 divided by 36. And then I'm going to hit equal sign. And that's what I get, 48.18. Now, in all spirit of transparency, I can't remember if the EOC calculators have parentheses or if you have to remember to put the parentheses in. It's very important that whenever you do this division, like order of operations, you have to put the parentheses in. All right, I'm not going to keep going through those examples because it's the same process, just with one more cosine and a tangent. Let's go to EOC questions. Here we go. Triangle ABC is a right angle. It wants us to find the measure of angle C. Here's angle C. Okay, and it says, what's the best approximation of angle C? So here, you actually get to pick what you want to use. Okay, so you could pick sine. Okay, so if you picked sine for angle C, you would end up getting, well, here's angle C. This is my opposite. This is my adjacent, and this is my hypotenuse. Basically, we have to do process of elimination. If we did sine of angle C, that would equal my opposite over hypotenuse. So my opposite value is 5. My hypotenuse value is 13. You see how labeling these matter? It really helps us out. If I do on here 5 divided by 13, I get 0.38. Okay, so this isn't going to make sense. It wouldn't make sense if I do this. See how I don't get one of those angle measures? I get something completely different. So we're trying to get 0.923. So it can't be sine C. That's not it. Okay, because we're trying to get the 0.923. Then, all right, we're going to do it again. Now we're going to do it with cos. Because if we did it that way, okay, if we just did 5 divided by 13, that gives us 0.384. And we're trying to get 0.923. So now let's do it with with cos. Well, cosine is adjacent over hypotenuse. All I'm doing is trial and error to try to get something in here. Well, my adjacent value for C is 12. And my hypotenuse is 13. So I take my trusty calculator. I'm not hitting sine or cosine. All I'm doing is 12 divided by 13. Look what I get. Shebang! 0.923. Okay, which is what I want. So I know my answer is cos. But I'm going to just keep going and show you tan real quick. If I do tan, tan is opposite over adjacent. My opposite value is 5. My adjacent value is 12. If I do 5 divided by 12 on the calculator, I get 0.416. So that's why we know it's got to be cos. Yay, us. Guess what? I know I'm going fast, but you're going to see it again in class. What? 1, 2, 3, 4, 5. All right, we got 5 left. You can get it. Okay, here's our next one. In the right triangle ABC. Guess what? There's no picture, so what are we going to do? We're going to draw a picture, because that's what we do. We draw a pic. Okay, so we've got triangle ABC. It tells you AB and B are complementary angles. So that shows us, here's our right triangle. If A and B are complementary, that means C has to be our right angle. The value of cos A is 5 over 13. So we know cos A equals 5 over 13. So we could just write it down. Here's my A. What's adjacent to angle A? Right here. What's my hypotenuse? 13. How did I know that? Because down here, I know cos equals adjacent over hypotenuse. Adjacent 5, hypotenuse 13. What is the value of sine B? Well, some people be like, oh man, I got to do work and figure this side out. No, you don't. Sine B is 5 over 13. Remember how I told you earlier today, early in this videos, that I said to you that like you have to know the complementary thing, where like cos A equals the same as sine B? That's exactly what that problem is about. You either know it or you have to draw it out. Either way, you'll get the right answer. Next, what is the value of cos A? So this is a lower level EOC level question. Here's my A. A is the angle I'm talking about. Okay. We know cosine is adjacent over hypotenuse. So I'm going to label it. Well, here's my right angle. So this has to be my hypotenuse. That means that the other side that makes up my angle is adjacent. And that means that 12 is opposite. So my adjacent number is 9. My hypotenuse is 15. Oh, shoot, that's not one of the answers. 2 ways to do this problem. Way number 1, you do 9 divided by 15 on your calculator, and you get 0.6. Then you do, let's say, 3 divided by 5 on your calculator, you get 0.6. 3 divided by 4 would give you 0.75. This would give you 0.8, and this would give you 1.6. So which one matches 0.6? Choice A. That's one way to do it if you're not good at reducing fractions. The other way that you could have done it is see that the numerator and denominator are both divisible by 3, and that's how you get the 3 times. Totally went fast, but we're going to keep moving on because I wanted to hit all these questions tonight. Next, in a right triangle HJK, what do we need to do? Draw the picture. Here's my right angle. J is the right angle, so then it doesn't matter where H and K go. The tangent of H is 1. Tangent, we know, is opposite over adjacent. So here's angle H. This is the theta I'm talking about. If it's 1, then this is pretty much going to be 1 and this is going to be 1. Or you can make this 5 and 5. But for the most part, we would just use 1 and 1. So then it wants to know which statement must be true. Well, there's 2 things that you could do. If you don't know this off the top of your head, the first best thing you can do is do Pythagorean theorem. Okay, so now we've got 1 plus 1 equals c squared. So we've got 2 equals c squared. So we get the square root of 2 equals c. So now we know all these values. So this says the sine of h, well, let's see. The sine of h is opposite. So we would have 1 over hypotenuse, the square root of 2. Well, that doesn't work. The sine of h is 1. Again, we know that this is what the sine of h is, so it can't be that. Well, let's see. It says the sine of h equals the cos of h. Well, again, we know the sine of h is opposite over hypotenuse. So that gave us the 1 over the square root of 2. We got the square root of 2 by doing Pythagorean theorem right here. Cosine of h is adjacent over hypotenuse. So here's my adjacent, 1. Here's my hypotenuse, the square root of 2. So it must be choice C. Okay. Again, I almost want to go back to the quote I showed you at the beginning. This is going to be challenging because if I taught you first semester, I taught you trig in about 2 days and you had your test. Some of you had first day, welcome to trig. Your second day was your test. So it's totally fine. Welcome, welcome. The bottom line is that what you need to do is like you need to probably watch these videos again because it will not be on your district assessment because trig's not in this semester, but it will definitely be on your EOC. So I know I'm going faster and I know you're going to have to work hard on this topic, but I know you can do it also. We're going to trash and keep going on. Okay. 2 more questions and then we'll be done for tonight. Next question. This is another EOC level question. 12-foot ladder is leaning against a building at a 75-degree angle. So here's our angle we're talking about. Theta, 75 degrees. Which equation can be used? Well, we always know the one opposite the right angle is our hypotenuse. We always know the one touching the angle is adjacent. So we know the other one is the opposite. So we have our opposite is x, and we know our hypotenuse is 12. So which of these trig identities has opposite and hypotenuse? So we're going to look down here on the formula sheet, which is really just this. I'm going to do proofs live this weekend because it's going to be so long. All right, so now what I'm going to do is I'm going to do sine is opposite hypotenuse. And that's what I have. So now I've got right here sine, and here I have sine. Well, I know my sine of 75 is opposite over hypotenuse. And that's going to be my answer. All right, last question. The hot air balloon is 1,200 feet above the ground. The angle of depression from the basket to the hot air balloon, is 54 degrees. Which equation can be used to find the distance d in feet from the basket to the hot air balloon? All right, here's my 54. Alternate interior angles lets me also put a 54 degrees here. Alternate interior angles are congruent. So now I've got my triangle. I've got 54, I've got D, and I've got 12, 1,200. So I pretty much have my opposite and I have my hypotenuse. So looking here, opposite hypotenuse is sine. So, and I know I've got 54 degrees. So it's going to be choice B. All right, so don't sign off yet. I just want to go over something real quick. At the start of tonight, the quote that I put up to share is strive for project, not perfection. If you are leaving this video session at like a 2 out of 5 or a 3 out of 5, that's perfectly okay. If you're at a 4 or 5 out of 5, that's fantastic. We're going to go through this again in class because so many people not misunderstood, but didn't remember things at the after school review session. I wanted to take the time tonight to at least activate some of your all prior knowledge so it's not new when we do it in class this week on Thursday and Friday. I don't know when I have Freddie this weekend, so I don't know when I'm going to do proofs this weekend. I should have a better idea probably on Thursday. But it's going to take a while. We got a lot of proofs to go through. And that's a longer lesson. It took us yesterday, it took us about a whole 2 hours to do. All right, we're going to stop there. I'm going to say goodbye, and I will see you all later. Thank you so much for coming, and I'll see you in the morning. Bye-bye, guys.